Okay, I'm so sorry. I know I promised that the last video was my last video. The previous video was my last, but I was almost to the end of shooting it, and I realized at some point I switched from problem one to problem two, and all my numbers were off, and I was like, what have I done? So I cut the end of the video, and I'm making one final video to finish problem one. So, yeah. Anyway, I'm tired. I'm sure y'all are tired too, but you can always stop this and come back to it. So here's the last thing we did is we figured out the distance that we need by measuring from the middle of the area of convergence to the edge of the blood drop. And then we looked at the length and width of one of the blood drops that they told us to use. We figured out it was 17 millimeters, sorry. And then we converted that 17 millimeters to 3.4 feet. And then I think this is the part we left off at. And this is the part that's wrong. Okay, so I can't remember if I cut the video before I showed that. So don't worry about that part. This is where we left off, I think, on the video. So now I messed up, and this is where I jumped to problem number 2. So yeah, you actually, if you watch this video, you now have the measurements you need for problem number 2. Okay, so we're going to finish problem number 1. Okay, we did the convergence we used. So now we want to use a blood droplet number 1. Oh, in the previous video, I was saying, I'm not quite sure which droplet they used. Again, my brain is just toast. They tell you to use blood droplet number 1, and they tell you to use blood droplet number 1. But I noticed when I was checking the answers so that we're all on the same page, that the distance they used blood droplet number 1, but for this next part, they totally used this blood droplet. So I don't know. I may just go back in the data table and give you all the lengths and widths of the blood droplets and let y'all go back and figure out angle of impact so that everybody's using the same blood droplet. But we'll see when I'm done making this one. So anyway, so the next thing I need to do is figure out my angle of impact. So I'm going to take this blood droplet and I'm going to measure my length and width. And when I measure the length of this one the width. The width of this one is about 3.5 millimeters. Okay, so my width is about 3.5 millimeters. And then my length, when I measure from the edge of the blood droplet to there, is about 7 millimeters. Okay. So I don't know why they said to use blood droplet number 1, which is they did for the distance, but then they used this one. We're going to just do that on the example because I want us to all come up with the same numbers. So we've got 3.5 by 7 millimeters. So we know that to find the angle of impact, we divide the width by the length. So we're going to divide 3.5 by 7, right? And that actually just comes out to 0.5. Okay, so then I want to use this to figure out my inverse sine. Okay, I need to find the inverse sine of 0.5. So I'm going to go to the back of my table of sines, or actually, you know what? Let's just use our calculator. It's easier. Okay, I'm going to open up my calculator. Where's my clear? Okay, I'm going to put in 0.5. I'm going to do the second button so that I have the inverse sine button. Hit the inverse sine, and it's 30. So 30 degrees is what I need to know. Okay, the inverse sine is 30 degrees. So that is my angle of impact. Okay, now I think I know everything that I need to know to do the final step. Okay, my final step, remember to find the height. Okay, in order to find the height, which is the last piece we're trying to find, okay, because we've done width and length, and we used a calculator to use the inverse sine, and we came up with the angle of impact. Okay, so we did that. So the last step, number 7, says use the law of tangents to determine the area of origin or height, okay, height of the source of blood. Okay, so I need to find the height. That's what I don't know. And so we said we can use the tangent of 30 degrees, because that was what the inverse sine was. and it is going to be equal to the height over the distance. Okay, what was the distance? What was the distance again? If I rewrite this, the distance, we calculated that back here on the previous page. It was 3.4 feet. So that was 3.4 feet. And then I need to use my table of tangents in the back of the book and look up 30 degrees. So when I turn to that, my 30 degrees is right here, 0.5773. So I'm going to put that over here, 0.5773. And in order to solve for height, we're going to multiply both sides by 3.4. Multiply this by 3.4. These cancel out. And when you multiply 3.4 by 0.5773, you get 1.969. Okay, which is what my height ends up being. But we're gonna just approximate that to 1.9 feet. So then that ends up being the final. You'll see this number and this number and this number and this number. All of these numbers are going to already be on the data table when you open the Google Doc. Okay, so let me kind of show you. So that is, we're done with problem number 1. Okay, so you're going to do the same thing for problem number 2. Okay, 17 millimeters is the, oh, sorry, don't look at that. That was me making a mistake. That was when I messed up earlier. So don't look at that. Okay, you're going to come over here to problem 2. Don't look at that either. And you're going to measure these blood drops. And it tells you to use blood droplet number 2, blood droplet number 2. This is blood droplet number 2. Go ahead and use blood droplet number 2. Oh, it looks like I already put up. It's 18 by 4 millimeters. So you already have your width and your height on that one. And then I'll go ahead and help you out on problem number 3. Which one do you need to use? You're going to use, what's it tell you to use? When you go on to the next page, it tells you to use blood droplet number 3. Okay, so let me go ahead and, blood droplet number 3 is right here. And I'll go ahead and tell you what the distance, the width and the length should be. 4 as your width and 9 as your length. So if you just use those numbers, then you should be okay in solving number 2 and number 3 on your own. So I'm going to do one last thing here. I can make this work and go to our classroom. And when you're looking at this assignment, oops. Okay, you're going to see all of these videos down here. Oops, I'm on the wrong assignment. After watching all the videos, you're going to see this, which is going to take you to a document that everybody will have their own document, but you do need to put your name on it because when they get submitted to me, they don't have your name. So please put your name on this. You're going to see that this is using your notes from the video lesson. We did problem 1. You're going to be doing problem 2, and I kind of restated the instructions that are in the book, but I combined them. Like this is all steps 1 through 4 together. This is a workspace where you can type in your work here, and then you will come down and do problem 3 and type in your space here. And then this is all the numbers for the one that we just did. We figured out the distance was 17 millimeters. The actual distance after we converted it was 3.4 feet. We measured the length and width of the blood droplet, came up with a decimal, figured out what the angle of impact was, which was the inverse sine. We did that on the calculator. Then we looked up in the back of the book what the tangent of this angle would be, and we came up with that number. And then we finally did some multiplication and came up that the height was 1.9. So this is the one that we just worked, all in the book. Okay, which you can't see it because I've switched the camera. But this is what you're going to finish now on your own. Okay, if you get stuck, message me. If you were paying attention and taking notes, you should be able to do this. You guys got this. All right, good luck. And get this submitted. Make sure you put your name on this and make sure you submit it on the Google Classroom when you're done. Okay, I'm going to sign out. See you guys later.